Okay, all right. Thank you, everybody. Yep. Just as you take your seats, I just draw your attention to your carry bags. There's a number of goodies in there, but one in particular is the blue evaluation form. Obviously, we'd appreciate very dearly if you take the time to provide some quality feedback on the evaluation form, and it just might be a bit easier that you actually do the evaluation on the run from speaker to speaker rather than leaving it all to later tomorrow. Yep. If for some reason you have to part away only at the end of today, please make sure you do fill out the form just for day one as well. So evaluation forms in your kit bag, please consider filling them out. Okay, if we could just have the door closed. Thanks, Sarah, because of the whistling noise. Thank you. Okay, so we're starting a session 2, and session 2 is actually entitled, Are You and Your Sheep Ready for a Value-Based Lamb Supply Chain? To lead this session off, Graham Gardiner, Associate Professor in Biochemistry, Nutrition, Toxicology at the School of Veterinary and Life Sciences at Murdoch University in WA, will lead the session. His research focuses on the physiological responses to selection of growth, leanness, muscling within sheep and cattle industries. Graham coordinates the National Postgraduate Program of the Sheep CRC, a lot of the R&D grunt done within the meat science and wool areas. He also supervises personally 8 PhD students, and he's predominantly funded by the Sheep CRC and Meat Livestock Australia. Graham coordinates the Sheep CRC Project, estimating carcass values based on lean meat yield and eating quality, and is most appropriate and probably the best in the nation to give us the latest in the development and technologies to measure carcass yield and meat eating quality in processing plants. Please make Graham welcome.
Thanks very much, Bruce. So today I'm going to run through a bit of a story. So I'm going to begin by just highlighting the need for what I'm going to call the next generation of the Meat Standards Australia eating quality prediction system. So that's where I'll start. I'll then outline that CRC project that Bruce just alluded to then. That's all about developing both the MSA system and these measurement technologies. And then lastly, I'm going to give you an update on what those measurement technologies actually are and how we're progressing. And the rate of progress is a bit sporadic across those, so I'll give you a bit of a feel for where we're currently at. So the last sheep CRC was quite essential. It really gave us the opportunity to drill down into these 2 key traits on lean meat yield and eating quality, to understand them in a great deal more detail and understand the correlations that exist between those traits, and also to improve the precision of the existing breeding values that we've got for selecting for them, in particular these ones, so post-weaning weight for growth and also post-weaning eye muscle depth and fat depth for lean meat yield. Importantly, it also enabled us to develop new breeding values, and I was just listening to Brownie deliver a red-hot talk just then all about the improved precision of those random wool traits, which I'm surprised people actually breed for anymore. But anyway, the meat traits, which are quite essential, have also had their precision greatly improved. So there's a few research breeding values coming online. So those represent the early tools that you have access to start pursuing the eating quality of the animals. But most importantly, the key thing that work all demonstrated was the fact that those 2 things, lean meat yield and eating quality, are antagonistic. We sort of knew that already, but what we really worked out was just how powerful that antagonism was. It gave me a bit of a fright. I hadn't expected it to be that strong. So effectively it's saying if we were to just close our eyes to eating quality and go flat out pursuing lean meat yield, and obviously you've heard this story over the last 10 years, but this really illustrated just how bad for the industry that would be. So it was that really highlighted the need to improve the eating quality prediction system. So at the moment, there are some price signals out there for lean meat yield, fairly crude ones I'd say, just with respect to penalties for overfat and underfat carcasses. Hopefully that'll get better. But at the moment, there's not really much of a price signal out there in the market for eating quality, which I think is a key factor that needs to be addressed. So to approach this, we've been developing what I call the next generation of MSA. So this is a prediction model based on individual carcass measurements. And we've already got a working prototype. You can see it right here. So in effect, you can enter in the breed type, whether it be maternal, Dorpers, Merino or terminal sires, and you then enter in the individual carcass measurements, which I'm highlighting there. So things like hot standard carcass weight, intramuscular fat percentage, there's eye muscle area, and GR tissue depth. And then that will give us the eating quality prediction in scores out of 100, at the moment just for the loin and the top side, but we're gradually planning to increase the suite of muscles that we've got predictions on based upon collecting that data. So the tool is already crudely in place, and as we build more data, the precision of this will further improve. But it really begs the question, doesn't it? How the hell do we measure that lot? So obviously abattoirs have got a great set of scales, and the hot standard carcass weight measurement's fine. The rest of it has got real issues. Now you might try and tell me, oh come on Graham, we've got GR tissue depth being measured in abattoirs, but I tell you we haven't. So if you think that palpation is sorting it out for you, here's the effect of using, or here's the ability to predict the amount of lean in a carcass. And this is a really accurate number, by the way, measured using a CAT scanner. So here's the ability to predict that lean using hot carcass weight and palpated GR tissue depth. Now, if you call that a measurement, then you're a fool. That's a mess. So quite clearly, we need to step up from that. So it's for that, it's that basic premise that's driven the structure of the current CRC program. So this is the extension to the old CRC. And there are two key projects within it, one based on online measurements and the other one based on a Meat Standards Australia prediction system using individual carcass measurements to predict eating quality of cuts within the carcass. If you like, a bit like what we've currently got for the beef system, but developed for lamb. So just to drill down on, effectively I've illustrated what the plan is here and that we've already got a working prototype. So let's drill down a little bit on this online measures project, and in particular, the things we're checking out, the devices we're testing for estimating lean meat yield and eating quality. So at this stage, we've got quite a list that we're planning to work through. There's a whole stack of developing technologies out there, and you've got to be careful here. Just because they're developing it, it doesn't mean they're ready to be delivered. There's very practical issues about putting devices into abattoirs, like if they get sprayed with a high pressure hose, do they still work? Now, the bulk of what you see there cannot handle a high pressure hose spraying it. So it's real simple stuff, but there's also the technological side of it that also needs a bit of work. So, you know, things we've got in our sights, this biological tattoo. The idea here is you can actually tattoo in fluorescing chemicals into the skin of animals, maybe on their nose, that might pick up maybe repro hormones, or perhaps stress hormones that are linked with glycogen metabolism and therefore dark cutting, or their pregnancy status. We're looking at, there's a device called a Raman technology. Unfortunately, there's only one of those in the world at the moment, so that's a good long way off. But we've looked at the practicalities of using that for determining myoglobin concentrations and therefore iron in meat and how red it is. Also the fatty acid profile and potentially even tenderness. There's near-infrared spectrophotometry, computed tomography, and I showed you a CAT scanner predicting the lean in the carcass a second ago. Now, obviously, we're a fair way off putting a CAT scanner in an abattoir, but nonetheless, there are a few devices being investigated on that front. High-definition video analysis, which is a little bit like a ramped-up vice scan, I suppose. So, new company, new technology, reworking that area with the improved vision devices that are now available. But in particular, for the next 12 months, it's this top section here that we're going to be focusing on. So, there's an impedance probe. There's a thing called hyperspectral imaging, so special cameras that can create very detailed images, and also dual X-ray absorptiometry. So I thought I would spend the time this afternoon just detailing the progress on those three things. So I'll walk you through where we're up to and perhaps the promise that those devices are showing. Or not, in the case of the impedance probe, which is targeted towards measuring intramuscular fat. So it's been developed by this company here, Carcase. So they're a Danish company that are quite famous because they've rolled out a thing called the Autoform, which is used extensively all over the world measuring the back fat on pigs. We actually looked at the potential for ultrasound in lamb. One of the problems with ultrasound is that air bubbles block it. Now, you know when you tear the hide off an animal, when you tear the fleece off, and you get that bubbling over the surface of the carcass, well, that mucks up the measurements. So that represents a very simple block to that technology. Possibly the Autoform capturing measurements right along the back could still be an option, rather than just a single point measurement based on ultrasound. But at this stage of the game, the business case around that is a little way off. So we've shelved that for now, and Keramatech instead have focused their energies on an impedance probe. This is it here. In effect, it's inserting these probes into the muscle tissue, and the electrical impedance between the points on those probes correlates with the composition of that muscle. In particular, what do you reckon fat would do to the ability of electricity to flow? Blocks it. It's an insulator. So therefore, if it's got more intramuscular fat, you get more impedance, and that correlates. And you can pick it up electronically as a little data measurement, which correlates with intramuscular fat chemically. So it does sort of work, but the correlation is far too noisy at this stage. We're still undergoing testing of that, and this year, all structured around MLA's nucleus flock. So you've probably, I'm sure this group have all heard of the nucleus flock. So that represents a sensational experimental resource. Every time we want to go in and check out any device, we just dive straight in and take measurements on those nucleus flock lambs. It's unbelievable having that resource experimentally at your fingertips. So we go in, we measure the nucleus flock lambs using this device, and we will see if the correlations, the impedance correlations with intramuscular fat improve. So the idea is that we'll insert that into the loin muscle. Probably around about the 12th rib, 5 centimetres from the midline, roughly the same point that you're currently ultrasound scanning over the C site there. So we'll get those measurements at that site, and in addition to that, there's a good chance that this probe may be able to measure tissue depths. And because of the impedance, there's a good chance it can also pick when it's gone from fat into muscle tissue. So therefore, as we penetrate those probes in, we can get a fat depth and a muscle depth, which of course will be pretty handy. You guys are generating fat depths and muscle depths systematically for your breeding values. So we'll get the abattoir end of that measurement. We hope. So that's the plan. But like I say, at the moment this technology is noisy. At worst, it'll be able to measure GR tissue depth in the same way as the old Osmeat sheep probe did. No better or no worse than that, exactly as well as that did. And by the way, that device worked quite well. Couldn't keep up with modern chain speeds, but that old device worked quite well. Okay, so that's the impedance probe, and at the moment I'm feeling a bit pessimistic about that on the basis of the early data that we have. The next angle of attack for us with respect to intramuscular fat is this thing called hyperspectral imaging. Now here's a picture of some hams, so some Danish hams. This is pig work. And you can see the photographic image, and then you can see how through a hyperspectral image you can differentiate the bone component, the meat component, and the fat component from that original image. Now, just looking at that, do you reckon you can pick it by eye where the bone is? You sort of can, but it's a bit tricky, isn't it? So you're sort of looking for these little circles up in that image. So you can sort of pick them. Nonetheless, this camera partitions out those tissue types with a good degree of precision in pork. I can't see any reason why it won't work in lamb. And so for that reason, the group in Denmark, Keramatech, have actually put together the first prototype of a hyperspectral camera. Now, those nucleus flock lambs I was telling you about, we're going to test it out on those. So this year there's going to be a series of kills, and we'll be capturing those hyperspectral images, which look a bit like that, across all of those kills. Of course, intramuscular fat is measured routinely in those lambs, in the lab, chemically. So therefore, we're basically sitting on the data set already to test the ability of that device to predict IMF. Like I said, those nucleus flock lambs, fantastic resource. Now, the other potential with respect to this hyperspectral camera, what you're looking at here is the robot sitting in Bordertown right now, boning out lambs. And Dave Rutley is actually going to come along and talk more generically about processing capability and robotic technologies, among other things. Of course, Dave Rutley is going to be representing Thomas Foods International, and they don't have this robot in their plant at the moment. So this is a JBS device, this one at the moment. So the idea is potentially that one of the cameras that are swinging off that robot, currently capturing images, you can see the loin muscle right there on the saddle region of the carcass, which has been cut. So that is quite essential. It steers the robot, tells it where to put things. Now, what about we swap that camera out, put in a hyperspectral camera, capture our intramuscular fat information, and steer the robot at the same time? No reason why it shouldn't. So it's that adaptability which underpins why we've got to work quite closely with these robotic technology companies, such as, in this case, Scott Technology, who deliver this robot that you can see here. So there it is, hyperspectral camera potentially capturing images of that eye muscle right there, potentially giving us a real-time intramuscular fat measurement. So it's not just intramuscular fat that can be measured using that hyperspectral camera. Obviously, it'll be able to determine eye muscle area. You don't need a hyperspectral camera for that. You can just use a normal vision camera. Hopefully intramuscular fat colour, so the yellowness of the fat. Meat colour, which of course is quite important with respect to dark cutting, and currently not graded in lamb. Subcutaneous fat depth, and also potentially just based on one site, maybe scores of ossification, and also the separation of fat from bone and intramuscular fat, particularly it being clouded by bone dust. So this is the sort of stuff that hopefully this device will be able to tease apart. Now, we have also tested a number of other devices. So there's the old Osmeat sheep probe, and that works perfectly well. It's old technology and currently not supported in the industry, but you know, the new age Keramatech device will do exactly the same job as that. And like I was saying, we've also used ultrasound measurement at a single site to try and predict fat and muscle depth. A bit problematic with respect to air bubbling there. Now, the one thing that all of these devices rely upon is individual site measurement. So I'm always talking about this. You know, we go in here and we measure either the muscle and the fat depth at that site or the intramuscular fat at that site. And I'm a little bit concerned about that. And it's on the basis of the last CRC results that really highlights that concern. So what you're looking at here is results that spin off CAT scan data. So that last CRC with the information nucleus flock, we CAT scanned subsets of those lambs across the 5-year period that those lambs are slaughtered. And from that data, we were able to work out that across the range of post-weaning eye muscle depth breeding values that were inherently in that flock, and that had a range of 7 units, so 7 units of post-weaning eye muscle depth. So across the extremes of that range, the lean in the carcass increased by 4.2%. And of that greater amount of lean that was there was 5% more lean in the saddle and 5% less lean in the forequarter. That's a fantastic result, incidentally. If you haven't worked that out, that's a brilliant result. Which bit's most expensive? That bit right there. It's exactly what processors want. But you know what? If you were just measuring at that site there, only one measurement to predict whole body lean meat yield, how are you going to pick up that effect? You got no hope. You can't do it. All you can do really is describe the mean of the population. So in effect, what this really highlights is the need for us to move towards systems that can measure whole carcass lean. So moving away, if where possible, moving away from single site measurement to quantitative whole carcass measurement to improve our precision of what's there and potentially capture those redistribution effects that are already happening in your lambs. And that's where DEXA comes in. So this stands for dual X-ray absorptiometry. Now, it's quite a nice opportunity. So that robot that I was talking about, which has been developed by Scott Technology, which is sitting in at that Bordertown plant at the moment, has been driven by a 2D X-ray. So basically it just consists of a couple of panels and an X-ray tube. And so the carcasses swing through a tunnel. The X-ray tube sits on one side, the detectors, the panels, they sit on the other, and just as the carcass swings past, you just fire the X-ray tube, pass the X-rays through it, and you detect them on the other side. And you can, using that 2D device, you can build up a really nice image of the skeletal structure of the carcass. And using that image, you can effectively identify skeletal landmarks, so that where you've got your big saws that put in a cut, say between the 4th and 5th rib, and between the hindquarter, those saws can really be precisely directed to make that cut without needing a person to do it. So that's what they were currently using, and the opportunity here was to come in and adapt to that system. So in effect, not really change anything, but improve the image by adapting it to a DEXA device, which really simply means going in and changing the detectors. I'm sort of underselling this a bit. It did take us 2 years to work out how to do this. But nonetheless, it's as simple as a sandwich detector, so a low energy and a high energy detector that pick up the photons from the X-ray tube as they pass through that carcass. You end up with 2 images effectively, one low and one high. And it's quite nice if you take the ratio of the attenuation of the X-rays passing through the image, whatever. You end up with an R value, or a ratio value of those 2 images. Now that R value is a pretty handy thing. So what you're looking at here is the R value for different elements. So cast your eyes down this list. So hydrogen's got an R value of around about 1, carbon 1.2, nitrogen and oxygen 1.3, 1.4. Now what's bone made of? Stuff like calcium, potassium, chlorine, sulfur. Check out the R values on that. So of course you can imagine that if you were to determine the R values on different tissue types, which has been done of course, so here they are. So there's fatty acids, R values around about 1.2. Protein, so muscle, R values around about 1.3. Now where's bone? Here we go, bone mineral, calcium hydroxyapatite, even the soft tissues of bone, all getting up around that 3 mark. That's pretty handy. You can actually take an image and then go to the pixels in that image and work out whether it's bone, muscle or fat, which in effect is what we've done. So you can see here, here's one image out of a leg, and using those R values, you can actually pick which bits are bone, which is what we've done here, and delete them from the image. It's pretty important. To be able to work out the ratio of muscle to fat, you've got to get this back to a two-part mixture. So that's what we've done. We've deleted the bone. You can see just visually it works quite well doing that. And then with the remainder, you can actually convert those R values into the equivalent percent lean. So this was, we worked this up for both lamb and beef, just to give you a bit of a feel for the fact that it's got a good relationship, nice linear relationship across the increasing range of lean percentage from 0 all the way up to 100%. You can see those R values change across that range. So the proof of concept, if you like, the lab-based delivery of this looked pretty good. The other handy thing, of course, is that you've got to determine what pixel it's associated with. So these outside bits are only a skinny bit of muscle, and the middle bits, they represent a lot more. And you can actually, using those x-rays, you can determine tissue profiles across it as well, so you can work out depth. So you've got a combo of composition and depth to give you quite an accurate estimate of bone muscle and fat percentage. So where to next? Well, it was time to go and correlate that with our gold standard measurement, CT lean. That's what I always come back to. It really nicely partitions up these carcasses into their bone, muscle and fat components. And just to give you a feel for the early demonstrated precision of this device, we're looking here at the percent fat in the carcass, measured using a CT scanner. And you're looking here at the DEXA lean value. So in effect, as that DEXA lean value's gone up, the amount of fat in the carcass, measured with a CAT scanner, has gone down. And the R squared was pretty handy, so that was 0.88. That was quite encouraging, so we thought, all right, we've described 88% of what's going on. Let's have another go, which we did. So here's the next data set. Take note, and I won't try and hide this. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9 carcasses. All right, so I've got to be careful not to oversell this. There's only 9 carcasses here. Nonetheless, a nice association again. And then we did it one more time and it was better still. Again, 6 carcasses this time. So the data sets are very small. The proof of concept for this device is very limited. And at the moment, the results aren't much beyond the lab phase, I would have to say. In effect, we'll nail this with a great deal more data. Now, you might say to me, okay, Graham, so, that's great. You've got this lab-based technology. How far off is it? Well, I'll tell you how far off it is. This week, I've got a couple of fellas over in Bordertown that are scanning 50 carcasses. They're not the nucleus flock ones. We decided to just dive in before the nucleus flock kills and just grab something random. Really light, really heavy, really fat and really lean ones across that range. So we're right now this week generating the data set to calibrate the DEXA device that has been installed at Bordertown to drive their robot and give them this easy access lean meat yield estimate, which hopefully, and I say hopefully because I don't know, will have precision that was demonstrated in the lab. So I'm quite hopeful that I end up seeing that level of precision. But I've got to be conservative at this point in time. I've got stuff all data and I haven't demonstrated this in the real world. So I've just got to be a bit conservative and say that whilst this is close, I don't know how it's going to go. But ultimately, you can sort of see the picture. We're going to have DEXA, we're going to have potentially a hyperspectral camera, and who knows what other technologies we actually come up with. Sitting in abattoirs, measuring carcasses, giving us a real-time information flow into the livestock data link, and discussions have already started with this team with respect to feeding that information in. We've got to get agreement between processors to feed that information in, of course, so it's, there's a fair bit of water to pass under the bridge yet. But that central data depository will then be able to feed that information into the sheep genetics database, into the MSA prediction system to give us individual carcass prediction. And of course, direct feedback to producers. So that's the vision of how we're hopefully going to plug all of these measurement devices into a data flow that's facilitating the power of that livestock data link system. So in effect, ladies and gentlemen, you've seen the yield measuring and eating quality measuring technologies that are being developed that are essential for the next generation of MSA. Quite essential to give us eating quality prediction so that we can start at least getting data going back to industry, if not followed by a price signal, to drive improvement in eating quality. You've seen I suppose the relative poor performance of the impedance probe so far, so I'm not going to oversell that one. You've had a quick look at the hyperspectral imaging technology and our plans for testing that out this year, and you've seen the precision, the early precision for that new DEXA device. So there's a fair bit of action to come in the next 4 years of sheep CRC project activity. So stay tuned, and hopefully this whole picture delivers as well as what I'm suggesting it may do. Bruce.
So we'll open the floor now to questions of Graham. Yep, just your name, thanks.
Alan Kelly, Graham. Is there any issues with the physical invasion of the muscle using the impedance probe?
With the physical invasion of
Yeah,
the muscle?
as in
okay.
poking something into a muscle.
Yeah, there's holes in the muscle, yeah. So
For
it's
the
done on the
consumer.
carcass when it's hot, and those holes close up straight away so that you can't actually see them. It can also be done on the carcass when it's cold, and in that instance, you can still see the holes. So the carcass is set, and so you get these small pinprick holes. Look, the feedback from processors and retailers has been that won't matter much. There's always a number of processing cuts in the retail cuts that are put on display in supermarkets. So the early indication is that they're not too concerned about that. But it's a fair call. It's something to watch. Yeah.
Yep, from the floor down here. Can we just hand this along?
Yeah, Joe Darlitz from Cummins. Graham, enjoyed your talk. We've been measuring carcass traits for a long time and looks like we're still going to be doing it for a long time, and things are developing quite well. When, as growers, do you think we're going to get paid from the abattoirs for meat yield or whatever?
Or eating
fat
quality.
depth. Hey?
Or eating quality.
Or eating quality, yeah.
And in fact, it actually ties in with the question that's up on the screen at the moment as well. So I'm not going to speak for processors because I'm not one. I'm a researcher, and I don't manipulate the markets. I just simply deliver the devices to facilitate those people to do so. But nonetheless, we're working very hard with the supply chains. We really are, through the sheep CRC activities, to make transparent the business case around measuring lean meat yield and how much money they can extract out of it, and also the business case around measuring eating quality. Now, all you can really do is show them the numbers, and then they themselves say, okay, maybe there's some process change internally that we can undertake to capture some of that value ourselves. And then they start saying to themselves, well, if it's so valuable, we better damn well start sending a price signal back to industry to demand those lambs. I'm hopeful that with these technologies in place, the capacity to do that will be there within the next 5 years. And certainly the conversations that we've had with processors are always along those lines. But you know what? I do have to back them in a bit here. Confidence based upon palpated GR tissue depth is very low, and so it should be. And to underpin a price signal on that basis, I would be concerned about as well.
Yep. Further questions? That was one. Yep. John?
John Corbin, can you explain how you get the data from the commercial carcass back into the stud breeders system?
So, in effect, I suppose it's the wonders of the internet. There's a few concerns around internet speed, but in effect, you've got an electronic device in an abattoir taking these measurements, and as they take those measurements, it gets stored on a hard drive. That information gets loaded up to a different hard drive through the optic fibre or the telephone wire, which might be located centrally at MLA or somewhere else, who knows. There's even been conversations with provider companies that could also give us those facilities. And then from that central location, it'll feed again down through the telephone wire back into, say, the Sheep Genetics Australia database. That information flow will just come in seamlessly, populating fields within that database. And then like Brownie can basically turn his computer on, press run on his next ASBV calculation, and up comes his new set of numbers. I'm sure Brownie would not say it's as easy as that, but nonetheless, that's in essence what's going to happen.
But won't each commercial carcass have to be identified?
So that's a good call. Won't each commercial carcass have to be identified? And so in effect, for this to really work, we'll need individual carcass identification systems within plants. There's a fairly big push for that in Victoria at the moment, and just recently, within the last round of Sheep CRC planning committee meetings, we've talked about projects around demonstrating online tracking in abattoirs to get that process rolling. Of course, if you are particularly motivated, I'm sure you could work with processors to get a kill sequence, so read ear tags off as animals are being killed, which is how we experimentally do it at the moment, and then just marry them up with the body numbers that come out the other side. And then you can track your data down that way. Look, this sort of stuff's a little way off, but it's a good point to highlight. Yeah. Now, Bruce, the thing I forgot to touch on was that question up there, which with respect to what would happen if a price signal arrived for lean meat yield before a price signal arrived for eating quality. So, for example, we get the calibrated DEXA up and running next week, and then it takes us another 2 years to get an IMF probe working. Could happen. I actually don't know. I can't predict the future, but it could happen. So, in the short term, I guess it's going to come back to breeders to use their own nous, recognise that powerful antagonism between eating quality and lean meat yield, and make strategic decisions to balance their breeding values. Now, Brownie and Andrew Swan, they're currently constructing indexes that will do that for you. Or, if you don't want to use an index, then I would suggest you get at the forefront of that development and work out how to balance it yourselves in your own studs. But that will be quite essential, and I think our only ability to control it in the short term is through the decisions made by stud breeders.
Graham, that's a very good point to pull your session to a close, in that you actually are challenging, empowering producers to actually start taking those measurements now, because of what you've got in the pipeline there. It's not going to be long before commercial producers are going to be getting, probably initially, lean meat yield feedback. You get a good measure of GR fat. Run that with the carcass weight, and you can get a fairly good estimation of lean meat yield. So that's not that far around the corner there. And then get some sort of technology that will measure intramuscular fat, and then you've got eating quality on the way as well. So no time like the present to get cracking on the measurement, I think, is the take-home message there from Graham. Thank you, Graham.